Good afternoon and welcome to the August edition of our Supply Chain Management webinar series. A few housekeeping things before we get started. If you have a question at any time during the webinar, you can raise your hand, and if I pick up the question during the webinar, I'll try to answer it right there. Or if you want to stay on the line after the webinar is ended, I'll be available to answer any and all questions when I close off the webinar. So here we go. This month we're talking about safety stock. And the question always comes up, what is the right amount of safety stock? If you talk to our friends in sales and marketing, they want us to have safety stock on everything so that they can promise delivery to our customers whenever and wherever the customer needs it. If you listen to our management and our friends in accounting, you'll find that they want us to keep our inventories to the minimum amount possible to reduce the money we have tied up in that investment called inventory. And that also goes along with safety stock. They want safety stock to be kept to a minimum also. Well, today we're going to look at three components of figuring out what the correct right amount of safety stock is. We're going to start off by looking at the data that you need to calculate safety stock. Then we're going to explore mean absolute deviation, a little bit of algebra. And we wind up with using a little bit of statistics and safety factors along with mean absolute deviation to calculate the right amount of safety stock. So data requirements. There are three areas that we need information in order to calculate safety stock. The first is we need a forecast. Forecast, textbook-wise, come from our friends in sales and marketing. Why? Because they're the ones that are out there talking to our customers all the time. They know what's going on in the marketplace. They know how our products are perceived and sell in the marketplace. They have the best information most of the time to give us a forecast of what demand is going to be period by period for a product that we make to stock. And I want to just take a small aside here. This conversation that we're having today is in a make-to-stock environment where you make the material, put it in stock, and then you supply customers from that inventory. There are other types of safety stock calculations, but the one we're doing today specifically addresses make-to-stock environments. So after we get a forecast from our sales and marketing friends, then we need to know what do we actually ship time period by time period in that supports those forecasts. In sales and operations planning and in supply chain management, we have that information at our fingertips. It's called the shipment report. What did we ship out this week, this month, by customer, by product? So that's the second element that we need. First, we need the forecast. Second, we need to track how we are doing against that forecast. The third element that we need comes from management. Management needs to tell us what service level they want to support their customers at. Management can use many different ways of making that statement. They can tell you things like, oh, I want only one stock out per X number of orders, or I want every line item shipped complete, or. But basically it comes down to they need to tell us what the standard is that we are trying to meet. We then can convert that standard into a percentage. For example, one order per week, that could translate, depending on how many orders we ship, as 95% of the orders have to go out from stock. So those are the data requirements. Remember, we need a forecast by period, of what we expect to sell. We need information about what we actually shipped against that forecast by period. And we need management to tell us what service level we are trying to achieve. From there, we move on to the next step. The next step is getting to the mean absolute deviation. Now, I don't know about you all, but in high school, algebra was not my favorite subject. And in fact, I failed 10th grade algebra, yet I teach it and I use it all the time. So it can't be that difficult. So defining mean absolute deviation. Mean is another word for average. Absolute means ignore the plus or the minus sign. And deviation is the difference from the standard, in our case, the forecast. Let's take a look at what this looks like. This is a simple set of data here. It covers 10 time periods. We're going to say they're monthly requirements. The second column is the forecast that sales and marketing gave us. They said 1,000 a month for each of the 10 months. The third column is what we actually shipped. This came from our records of the shipments that we made that month, put them out the door. And the third column is the error. The error in this case can be we shipped more, it's a positive number, or we shipped less, it's a negative number, or there was no error at all. We said 1,000, we shipped 1,000. I would draw special note to period number 5. If you look at how many we shipped that period, 1,400, that's 40% more than forecast. It's that type of error that we're trying to deal with safety stock. So just keep that one in mind. Now, if you notice also one other thing, the actual shipped for the entire 10 periods was 10,200. The forecasted amount was 10,000. So on one hand, that was a pretty accurate forecast. Now, we need to talk about the absolute deviation. So the final column here, number 5, is the absolute deviation. Notice it strips off the plus or the minus signs on each of the 10 periods, gives us the number of variation. We total that up at the bottom, and it comes up to 1,600 deviations over the course of that 10-month period of time. That is the absolute deviations, and if we divide it by the 10 periods, that gives us our mean absolute deviation of 160 units per time period. And for the most part, looking at the data, you can see that we stay pretty much within that 160. There are exceptions like period number 5, though, where we are well above it. So now we've gone and looked at the data that we need and how you use that data to calculate the mean absolute deviation. So let's talk about how you use mean absolute deviation and safety factors to calculate your safety stock. If you take any group, in this case here, what we have showing are a group of individuals, men and women of different ages and ethnicities. If I had them all in a room and had them sort themselves by height, lowest, shortest, to highest, tallest, we would come up with a distribution that looks like this. In a standard group of individuals composed of men and women, the average height is going to be around 5'6" or 5'7". If we use the data that we captured in calculating the mean absolute deviation, 68% of the people in the group will fall somewhere between 5'2" and 5'9". If we use 2 of the mean absolute deviations on the height of people, will most likely cover people from 4'12", 4'11", all the way up to about 6'2". So it's an average distribution. This is the statistics portion of the forecast of the safety stock calculation. Now, we need to talk about safety factors. Safety factors are a byproduct of the mean absolute deviation. One mean absolute deviation is a safety factor of 1. 2 mean absolute deviations is a safety factor of 2. And it goes on and on and on. If you get a book on statistics, they have chart after chart after chart that will give you the safety factors for any mean absolute deviation. For our purposes, to figure out safety stock, we need the service level that management told us they wanted to meet. For example, if management says they want 80% ship complete, then our safety factor would be 1.05. If they told us they wanted 95% ship complete, the safety factor would be 2.06. Here's what that looks like when we put it on the average shipment distribution chart. Our average shipments over the course of 10 months were approximately 1,000 units per month. One mean absolute deviation, in other words, 160 units. If we put 160 units in safety stock, we would cover 68% of the shipments during that period. We could guarantee that 68% of the shipments would go out complete. Now, remember this, safety stock only applies to those quantities above the average. By definition, if we ship 1,000 or less, we already have the material. Now, if management told us they wanted a 95% ship complete for this particular item, the formula for calculating how much safety stock you need is the safety factor, 2.06, that came from the previous chart, times the mean absolute deviation, which we calculated a few minutes ago, of 160 units. 2.06 times 160 is roughly rounded to 330 units of safety stock. We would have to carry 1,330 pieces in stock, of which 330 of them are safety stock, in order to meet management's goal of 95% on-time delivery. And this is where having this fact-based data helps you when finance or management says that's too much money to spend. You have the data here. You know it's 330 units of safety stock to support the 95% service level, and say it is $10 per unit. You can actually say, okay, this is how much it cost us to meet your service level. If you don't like the cost, change the service level. Another thing you can do, fact-based, if you want to reduce the amount of safety stock this calculation is creating, get a better forecast. Remember period 5 in the initial data where we shipped 40% more than forecast? That played a big role in driving the mean absolute deviation to 160. If you could have a forecasting technique, get our sales and marketing folks to use a different technique that could spot those types of anomalies before they happen, then your safety stock, based on this calculation, would be lower because your mean absolute deviation would be lower. We would be forecasting in period 5 that say, oh, we know there's going to be a blip here. That period, instead of it being 1,000, should be 1,250 or 1,300. Then, even though we shipped more than the forecast, the total absolute number is less, and therefore your mean absolute deviation is less. So let's look where we've been over the past 15 minutes. We looked at the data that you need to calculate safety stock. Remember, it's the forecast, the actual usage, and management's definition of customer service level. Then we looked at getting the mean absolute deviation. Remember mean absolute deviation, the average, forget about plus or minus sign, deviation, actual to forecast. Once we had that, we used safety factors along with some statistics and the mean absolute deviation to calculate the amount of safety stock you need to meet any particular customer service level. So that's all for this week, folks. I will be around online for the next several minutes to answer questions, and I see some are popping up here right now, so just bear with me for a second. Next month, in September, we're going to talk about ABC inventory management, and this webinar and previous webinars are available on our website via YouTube video. You can go there on our webinar page and pull them down at any time. So right now I'm going to open the floor up to Michael. Michael, you have a question?
Well, yeah, I just sent it to you. I was asking, is the mean that you're using for these calculations, is it the average of the forecast, 1,000 units per month, or is it the average of the actual sales, the 600, the 1,400, the 800?
Well, it's the average of the deviation between the forecast amount and the sale amount.
No, the 1,000 units, the one right in the center of the normal distribution.
That's just a rough estimate. If you took 1,200, I could have used that number, but we were so close to the 1,000 that sales forecast, I just arbitrarily put in 1,000 as a rounded number of the average shipments that we were doing.
Okay.
Okay.
Thanks.
All right.